Hello, everyone. Welcome. Thanks very much for coming today. My name's Scott. I'm responsible for growth at Pale Blue, and really appreciate you being here. Just to give you a heads up, we'll be recording this session, and we'll make that available as well. So no need to take detailed notes, and you'll have a recording you can rewatch or share with your colleagues if you want. There'll be two main presenters today, Snorre and Felix. I'll give you a brief introduction of each. So Snorre focuses on ensuring ROV access and operability of designs for the subsea market. He's been at Aker Solutions for 12 years and has led Aker's ROV access group for the last 10 years. Prior to working at Aker, he's operated ROVs, AUVs, and trenchers for 7 years. He also has experience in the aviation industry for SAS and also for the Royal Norwegian Air Force. Felix is our other presenter. Felix is the co-founder and CEO of Pale Blue. He holds a PhD in computer science. His background in technology has worked at companies such as Aker Solutions, MF Worth, Sun Microsystems, and also with ROVs for nearly 2 decades now. At Pale Blue, Felix leads development of 3D simulators and virtual reality solutions for our clients, which include companies such as Saudi Aramco, Neptune Energy, European Space Agency, NASA. So with that, I'll turn it over to Felix.
Thank you, Scott. Welcome, everyone. I will actually invite Snorre to talk about access check in general, how it's traditionally done and what it's done for. Snorre. Snorre, maybe you're muted.
That's correct. Always forget that. The whole idea with doing access checks for us in Aker is to ensure the operability of the equipment when it goes subsea. What's important to check is that you have the access to get the ROV into the work area, that you can stabilize the ROV, grab on, see what you're doing, and read marking, see indicators. That's basically what the ROV access is all about, to ensure that we have the operability when we go subsea. Back in the days after we had done the ROV checks in our CAD tools, folding a model around in SolidWorks is not very easy or pleasant in any way, and it doesn't give you a good representation of the access either, because you don't really have the camera, so you can't get the proper view. You don't have the same interaction with the arms. So using a CAD tool was very time consuming and slow, because when you load a lot of models into a CAD tool, it's hopeless to work with. And then after we did that, we went off to site and did site integration testing with a huge mock-up, lifted around with a crane, usually in tight spaces. It was pretty much the only way to get the customers' confidence back then. But with the new simulation tools, we're seeing that part of the scope disappearing more and more. And also during in the design phase, we use the simulator a lot for design reviews, because it's so easy to jump around with the ROV and show in the simulator rather than trying to explain a picture. That's really, really helpful. So I guess, is there anything I forgot to say?
I don't know if Roy wants to add anything from the access check perspective.
Like it's on the slider what traditional 3D tools are used. So we used to use SolidWorks, and we also use that today. But as Snorre said, that was really time consuming, and we had to move on arms and update pictures and so on. So that was hopeless. But yeah, I think you just continue, Felix, for next.
All right. Okay. So then I would like to say a couple of words of how simulators are transforming this field, and they have been available for quite a number of years now, specifically for design reviews and access checks, because instead of doing things in CAD that is not really meant for navigating ROV around, instead of making things with the hardware mockup and moving an ROV mockup around with a crane, you could have a specialized system meant for engineering reviews, design reviews, flying a ROV around the subsea structure, and actually performing the operations for whether that's accessing certain interfaces, operating certain tools, and so on. So there's a few key elements in that, and I briefly wanted to address those. Well, one of them is, for example, being able to load subsea CAD models, right? So, of course, those 3D designs are found in CAD packages, but the CAD packages are not really meant for efficient fly-through of the model, efficient operation, and there's no real physics typically in CAD packages. But the moment a simulator can load a subsea engineering CAD model, that enables one to really perform realistic operations on the actual data, on the actual 3D object. So another essential feature is, of course, steering the ROV itself. This is where, again, there's a number of approaches, but something that is typically a differentiator between a pilot training simulator and an engineering simulator is that with the pilot simulator, you want to get close to the real controls that one is using for piloting the ROV out there. And for the engineering simulator, you just want to get a job done as quickly and efficiently as possible, and hopefully also with a cheaper version of the controls. So I will say a couple of words with that, but yeah, so steering the ROV is essential, so that you're able to control the ROV, the hand tilt units, the manipulators, and of course that there's certain physics involved in steering the ROV, so you can land it on roofs of structures and such. Yeah, and occasionally they can be drift because of the subsea current. So that is a typical and one of the essential, of course, features for the simulator. And interface checks, right? So this is where it is to use the manipulators and the different types of claws to access different kinds of valves and interfaces and use the tools. So we have to have physics. Physics is important. And that's the high level of what a simulator for access check and the ROV is. Again, so it's probably kind of a middle ground between a CAD package and an ROV piloting simulator, because for the CAD package, you can't fly things efficiently enough, and for the piloting simulator, you can't really have CAD features. So it's kind of it's the best of the both worlds, optimized for design reviews and access checks, right? But you typically wouldn't have, say, the limited distance of view. You wouldn't have some other atmospheric effects, because that's not what you're looking for in engineering simulator. Yeah, I already said something about the tether management and having the tether management system, TMS, in the scene, because tether entanglement is a concern, definitely, and you have to be mindful how you pilot and how you operate your ROV and how you lead it into certain hatches and openings. So yeah, quite important to support that, quite important to be able to get your tether physically based, and so that you can get into tricky situations, you can get your tether entangled. So that typically is a part of what an engineering simulator is. And water current, as I said, would affect the tether, would affect some other objects in the scene, and also is a feature. Physics. Now this is where you get probably a lot of freedom in how realistic your scene would be set up. CAD packages by default, of course, they not always give all the joints the proper movement angles, and you have to put extra work in the CAD package itself in order to set up your model for movement so that the hatches are possible to open, certain tools are possible to insert. And this is where Axis Check Simulator like this would be instrumental in assigning physics to certain parts of the model, assigning movement limits, assigning collision volumes, and being able to, actually physically interact with things. So for the ROV to collide, for the ROV to land, for the manipulators to grab onto the structure, for tools to be used on the structure and such. So quite important to get physics when you need to. And but I also think that Snorre will talk about the balance between how detailed physics you want to have versus how much time you want to use on setting up physics, right? Because sometimes you just want to have quicker access verification without doing so much time and precise physics setup. But yeah, it's important the freedom to choose how much physics you want to have is there. And then it's up to the specific task. If you need a lot of physics, or if you can get away with less physics being set up. Keyframes and videos depends on the format of the work and the output of the access verification. If it's a deliverable to the end client, typically they want to have some images, videos showing how the access will be done, and it's also important to be able to save your operations to a set of keyframes for reproducing later. So CAD support, briefly, super important to access your CAD, super important to try to maintain as much detail as you want, and kind of size of the fields and size of equipment and complexity. There's a trend that, of course, the complexity is increasing, the size is increasing, and the tools have been able to address that, right? So if you're able to work in your actual CAD and actually update it with each design iteration, that's what you want to have. You want to load your CAD model of your subsea designs, and you want to be able to natively work on this model, spot any problems with the access, report them, get model replaced. So that's a feature that is quite important. I will not go perhaps into great depths of the model optimization, just because we're still working on the finite hardware, and you still need to do some optimization, but there's a lot of optimization that is built in these days, so you can do automatic optimization on a lot of things to make things run faster. Yeah, so keyframes doesn't sound like much, but it's actually proved to be a very, very useful feature. And when you're talking about keyframes, so usually you're thinking, well, some sort of animation for, I don't know, product showcase. But in access check scenario, it proved to be quite central in performing repeatability, repeatable access checks on the equipment, where you would kind of access some interface once, remember or kind of store the keyframes of how that access was done, and then actually playing it back with the updated interface. So keyframes is proved to be a very useful tool for repeatability and for saving efforts in the future of repeating the same interface checks again and again. Yeah, so envelope is also a very standard feature in many ROV simulators, especially the engineering ones, where you can have some safety volume with different colors that's sliding up differently depending on how much inflation there is. And probably I'll be just concluding on this part of my token here, just by saying that there's a number, of course, of ROV simulators out there that need custom hardware, especially the piloting simulators and piloting ROV systems that are meant for full-blown replica of the panels, interfaces, of all the knobs, and they run on custom hardware. And we're hearing from some of those companies saying, well, it's really hard to get a replacement these days. It's really hard to upgrade. It's really hard to manage bigger models, subsea models. That's why we made the choice of kind of making a system that's running on generic PC hardware, so off-the-shelf computers, and also, as I mentioned previously, so that we would be able to operate it with just standard off-the-shelf gaming controls, because for engineering, that's probably what you're aiming at. You're aiming at something that is efficient and quick, that doesn't break a bank when it comes to controls. So I'll conclude with that, and I'll ask also for Snorre to add his perspective on how simulators change the world of access checks.
Yeah, no, we can start at the beginning. I remember a long time ago where we had to take our CAD models, ship them off to a third party, wait 8 to 10 weeks, and then get to see something in a simulator. And by that time, they had removed 60–70% of the model to optimize it to run in the simulator. Not really any point of running access verification to a model that's been stripped down, because all the details are gone. And the devil is in the details. And we started developing ROV simulator, Felix, back in 2010.
Yeah, there was something like that. 2008 for kind of an early pilot version, and 2010 when it got started, we started to roll out.
And we were on a good path, but then that part of Aker was sold off, and they took the simulator with them. We couldn't use it anymore, and we've been through a couple of other simulators after that. They've been very limited in performance, so not really suitable for our needs. And when we won this small project off the coast of Australia, we realized we needed to do something, because we could not fit the amount of CAD models into any other simulator. So we reached out to Felix and Pedro to get a new simulator in place, and we did. And the process now is that we use XYZ for importing CAD models. And I do, well, hardly any optimization of the models. And, well, except for reducing number of materials, but that's not all that much. We could have done a lot more. But the need hasn't been there, because it's been running rather smoothly without the need to do much optimization. So we still have a lot of potential. And we're now running, I'm not sure if you're familiar with the JANS project, but it's a huge compressor station. We're running all of that with no issues, directly imported from CAD, with no other optimization and maybe removing some materials.
So with that, perhaps, Snorri, we could diving into more specifics of how the simulator is used and how you use the simulator features, so that we could talk about the specifics of how you go about and how you perform an access verification on the simulator.
Touched up on it earlier in an earlier slide, but the thing is that when we do access verifications for our designers in a project, it's always to consider the models as fresh goods. So you need to act quickly, right? You need to get the model, you need to put it into the simulator, do the verifications, get back to the designer so he can do his changes. So instead of having to wait weeks like we did in the old days, now we can do that in minutes. And also, in a design process, you kind of reload the same model many times. You're rechecking the same interfaces many times. And that's where we got the idea for the keyframes, which basically saves a snap of the ROV, arm positions, camera for that specific task. So when you then have to go back and recheck it, you can just click through the keyframes, and it's saving us hours and hours every day. Just that one function. It's been brilliant, and the fact that we also can use it to create animations afterwards is just a bonus.
Right. So perhaps if we could take kind of a broader picture in here and start with the basics of how you go about creating a project. What are the main points in that project? How you operate your ROV and how you add your CAD models. Something. So just starting from the level 0 in a way.
You know, we start by adding the startup scene, which contains the ROV. Of course, you can have any ROV model in here if you have the 3D models for it. Then we start importing the CAD models, and usually building them up so that we have kind of a holder folder on top, which keeps the keyframes. So we can change out the models inside as they are renewed or updated. The next thing on my wish list would be to have the physics we put on the model transferred to the new one as we import it. Here that's possible to do. So it's all about, you know, structuring the folders to make it efficient for the check and for the replacement of the constant replacement of the models. So very often I take stuff that's standard and put them to the side so it doesn't follow the CAD model, to not having to do too much rework every time we get a new model in. It's all rather efficient, and adding physics like for opening hatches or stuff like that, it's really simple. You don't have to spend much time on doing that. It's just when you start more complex things that physics takes time, and then for me it's not been worth putting in the time to do it. Mostly, we had a few cases where we had to be more of a proof of concept, and then we have actually put in a lot of physics with dynamic hoses and EFLs and stuff like that.
And maybe also worth mention that it's very easy just to copy a structure or an object as many times as you want without having to load it in again. So just Control D and you have it again and again and again.
Yes, and also for standardized products, like we have standardized our tie-in systems, we have standardized our Christmas tree systems, and all these standard components we can now export with the keyframes and reuse them in another project. Meaning I don't have to do much work next time I have to recheck the same Christmas tree in a new structure. It takes minutes rather than hours.
Right. So now that we're looking at this demonstration, I think this is what you've set up, Snorri, also using the measurement tools. Can you maybe say about how those are used in aligning objects?
You know, the measurements tool are really good. I wish we had the old Snap 2 object like we had for the first simulator we made. Remember that?
Yeah.
But I use the measurement tool all the time to position things to get it accurate. And it's real simple to use unless you have a CAD model that doesn't have a surface that's measurable. That happens, unfortunately. The thing is, you just click on one center and you click on another center, and then you see how much you need to move the unit, and just type in plus or minus in the transform boxes on top here, and it moves to where it needs to go. Really simple.
Once the measurements and the are there and the alignment is done, while you don't do and create physical movements for everything in the scene, would you still create physical colliders for like the main beams, the main structures, so you could land on things and at least get the basic collisions working?
You know, all the bigger structures are supposed to not move. We make sure to put the static tag on that so that it's easier to run. It doesn't demand as much from the software. And then we do put on colliders on like the frame around it, so that we see when we have a collision moving in. Our ROV envelope will turn red when we collide. And that's the usual. You don't have to, you know, move the picture around to see all the sides of the ROV. You can just move in and you get a visual straight away if you're colliding with something, and then you can check what's wrong.
Sure. So that's creating the collision volumes automatically based on the CAD models. So you don't spend too much time creating colliders, or do you sometimes go and create individual cubes and such for colliders when you need those?
I usually just click on the one that's going to be relevant for the check I'm doing, and then create colliders for that. I know if you put colliders on everything, it's going to run heavier.
Right. So then you have colliders on some of the static structures and perhaps some of the dynamic objects that you interact with when you need that. Okay. Yeah. So also maybe just explain the notion of the ROV envelope and how that's working, because yeah, in this demo you're showing that you have envelope penetration to the yellow and red zone. What's the purpose of that?
Oh, that's well, according to standards, we're supposed to have 0.5 meter clearance on all sides of the ROV. Right? Now, when we're doing the checks, it's also nice to know how much of a breach we actually have. And that we can set a limit, let's say 100 mil. The first 100 mils you breach, it turns yellow, and then after that, it turns red. It's giving me a kind of a quick and easy assessment of how bad the breach is. That can be adjusted on the fly. You can also adjust the size of the envelope. Although it's said to have 0.5 meter on all sides of the ROV, I think that having a 0.5 meter in front of the ROV is rather stupid, because you need the space to operate in front there anyway, and that's usually more than 0.5 meter anyway. So.
All right, so then you set those ignore zones on the front, not to have the color changing when you are operating in something closed?
No, I either just pull the envelope back to the front of the ROV, so that you don't have that green bit in front. And also the part that you as an ROV operator are seeing and are controlling, right?
Sure. Okay, so now that we've been talking about the basic principles, physics and such, you've addressed keyframes as well, and this is something that we are seeing here in the product, is that there's a number of keyframes that are set, and then I understand that you are configuring positions for the ROV and arms to be recorded in each and every keyframe. So the panel that you're showing in here, what's the case? Is this that you'll get several iterations of this panel and it will slightly change? What's the thinking process behind?
No, it might change. Valves might be swapped out to other types. They could rearrange the whole panel to fit new stuff into the Christmas tree or other units. So there's always iterations going through the design phase. And then instead of having to change or recheck all the interfaces with the keyframes, I can just flip through and see, okay, here's a change, here's a new one. Rest is good, fine.
Sure. Because the alternative would be to pilot the ROV again and again to the very same interface and repeating the same operations manually, correct?
Yeah, what I call stupid work.
Okay.
Doing
And
the same stuff over, that's stupid work.
The way you avoid that is that on your ROV fly-throughs on those operations, you kind of record keyframes, and then ROV automatically can repeat that over and over with the updated interfaces, with the updated revisions of the CAD model.
Yeah.
Okay, understood. So you're saying also it's a quite a frequently used feature that this kind of a keyframe access is used very often. Is that correct?
When I've done a project, I have keyframes for every single ROV task.
Okay.
So I use it for everything.
And I think you also mentioned that when you created the keyframes, they're kind of bound to an object. So say you have some sort of a Christmas tree. So can you explain how the keyframes are then connected to the Christmas tree, and how is that then beneficial going forward?
What we do is that we create an empty game object in Unity, and then we attach the keyframe script to that. And then we place usually the models on as children of that top level. And then for some reason, if I need to use the same Christmas tree in a different project, I can just export the whole thing with the keyframes. All good. And then put it into a new structure that might be different challenges, and I can just flip through and see if changes are needed or if it's okay to go.
Would this Christmas tree that you've created and you kind of attached the keyframes to, would it be reused elsewhere in the same scene, or like between projects as well?
Between projects in the same scene, like if I have a 6-slot template, I can just take that keyframe holder and move it to the next slot, and then just
okay.
clicking through everything to make sure it's good.
Understood. So since we're talking quite a bit in here about keyframes and animations, we'll get back to animations, but just to, again, maybe to reiterate that the physics are supported. So if you want to do full-blown physics, and if you want to do like realistic operations with full collisions, you have the full freedom to do so. Is that correct?
Yes, of course. It's built on the Unity's game engine, right? And you have a lot of functionality in there, so you can do pretty much anything.
And I feel like we haven't maybe kind of unpacked that. So what is it with Unity that makes it a good foundation for you in your work?
No, first of all, when we started developing, we had out of the box a lot of the tools we needed. So it was an easier development to get the simulator in place. And also because the potential that's in Unity for adding physics, for creating animations, for doing, if you want, full-fledged movies, the potential is there. And if there's something that's not available, it can be made and added.
Right, and I think that's a very good point, because quite often people ask me if the feature set that we see in front of us is that it, or kind of, can I get another visual effect, can I get another object or another, I don't know, measurement tool. And of course, Unity contains a huge asset store, and there's many different kinds of objects, functionality bits that are accessible in there, that makes this system very useful and very extensible. And there's a lot of content, good content, that could be then plugged right into your scenes and your projects. And as you started saying, of course, that's not the limit of it. You can always add more yourself if you wanted. So you can script things, you can set up things, you can configure things. And I think a part of this is, for example, how we address ROVs and how we treat ROVs. For many simulator systems, ROVs are just built in, and what you see is what you get, right? So there's a big difficulty trying to replace the ROV body or configure it differently. While we have taken a slightly different approach where ROV is just an object in a Unity scene, and we've made a wizard, so to say, to reconfigure and replace the ROV model also from CAD. So if you have another ROV body in CAD, it's possible to pull in. If you need to configure another arm or another manipulator, it's also possible to drag that in. So I understand that configurability also has been aiding your projects, Snorre.
You know, for me, it's all about the freedom, right? That we can make changes on the fly. We can make anything happen in here. We're not limited to a set framework. That's been really good for us.
So maybe from that, and we talked about Unity and extensibility and how open the system is. We talked about keyframes and how those could be set, and then you briefly addressed the animations as well, or say the timelines as they're called in here, allowing for smooth transitions between keyframes. So we kind of spoke already about you can physically fly the ROV, you can record those flies and those axes as you go creating keyframes, and then you can recheck interfaces again and again with the updates in CAD, with the new revisions of the engineering CAD work. So what is the request from your clients, Snorre, that prompt you to create those kind of animations? So because then I understand you're taking keyframes and you're kind of blending between the keyframes to create some sort of animation sequences out of those. So what's the end goal here?
No, to begin with, I just started making some short sequences just to kind of explain to the customers how things were supposed to be done. But I quickly realized that we have all the 3D models in here. We have tools that can make animations rather quickly. Why should we send this off to some animator to do the work? First, having to put down all the actions for him to do, then create special models that he can get to work with. Then you have to prepare these models and then create it, come back to you. You have to comment on all the wrong they've done, and you have to send it back again. It's been a lot more efficient to actually create animations myself than sending them away.
Right, and are you then using the same set of keyframes that you're using for interface checks, or are you creating like more specialized keyframes for animation?
For the ROV movement, I'm using the already registered ROV keyframes.
Okay, so there's no double work in here. You're just reusing the keyframes that you've done for your main.
You might add a couple of more keyframes to ensure that the ROV doesn't fly through steel between two of them, right?
Right, understood. Okay. I think we've covered a fair bit of functionality in here, and maybe also kind of before we open for questions and a discussion, also to ask you, Snorre, what would be the next interesting extensions of this functionality? Where would you see the system going forward? I know that we've done something for slicing, and that's also a feature that we are kind of recently have rolled out, and we haven't been talking about that. But what are the sides? Are you feature complete, so to say, or are there still things to do?
I don't think we'll ever be done developing this, because there's always new features, new functionality you would like to add, right? Sometime in the future, I'm actually dreaming of making myself unemployed by having an AI do this for me. So
wow, okay. So what does ChatGPT think about that? I don't know if you asked the question. All right. No, I was just asking if you already consulted with ChatGPT on that probability.
No, I haven't, but you and I have talked about looking into AI.
Sure. Right. Okay, this is brilliant. Okay, I think this was a brief demo slash feature overview from our side. Back to you, Scott.
Yeah, thanks very much to both of you. So yeah, I mean, we've got a few more minutes here. If anybody has any kind of areas they want to dig in a little deeper, any general questions, anything they want to share about kind of the problems or the challenges that you deal with on a day-to-day basis, or any questions or comments for either Felix or Snoya. Don't everybody talk at once.
Yeah, I know that Jan usually has quite a few questions, so I don't know if Jan wants to start.
Yeah, I normally have the difficult questions because I have a long wish list. My question first is, if I have an ROV, which is not a new standard model, I understand it's pretty easy to import it, but could I, for instance, fit them, select manipulators, change manipulator position, etc.? Would it gain the physics? Could I control the manipulator?
Yes, that's a simple answer. If you just have a 3D model of the ROV you want to put into the simulator, then you can put it in and put the arms on. You put pan tilt units on. You put the donkey dick on top to connect to the TMS, or in the back if you would like. Yeah. So yes, you can set up pretty much any ROV as long as you have the CAD model.
For the manipulators, the same principle applies. You have to put in the manipulated geometry into the project, and then for the manipulator specifically, you have to kind of link the joints and set the joint limits. And up to you if you're willing to do that, or if you want us to help with that, depending on your experience with Unity. Once the manipulator is there, it's possible to adjust where it sits, fit it into all the different ROVs. You can also change claws. So that's in the system.
Okay, I have a second question. I understand what you're saying. If but the animation you've shown now basically have one structure, what if I have a field layout with 20 structures? I would like, for instance, simulate how I would use an ROV to drag one jumper from one location and basically connect it to the next structure or the next module.
That should not be a problem. I think you can fit all the subsea structures in the world into Unity and make it run.
Oh yeah, it's a game engine, should be.
A game engine. No, so that's not a problem. You could get seabed scans and put in the actual seabed in the area and put things on top of that. You can do free span checks without even diving.
Mm-hmm.
I think an element in here would be to be able to organize your project structure, because as you sort of mentioned in the beginning, you would have to kind of structure it folder-wise for your geometry. But also if you have keyframes, you'll structure that as we support folders in there. So then you'll be able to have structure for the geometry and structure for your access points as well.
If I wanted, I can take up the whole rest of our time if there's no problem. But if I wanted, for instance, to simulate tie-in operations, I really know very well what a tie-in operation is. We basically connect pipelines subsea. But very often we want to simulate it because we want to sort of simulate how this goes in HACCPs, HACIDs. So how is that? Is that possible?
If you put the time in to put all the physics in, you can simulate anything, almost like real life.
So yeah, how complex would that be if we're talking about connecting two pipes? Okay.
No, you would need to have the added collisions, and that's usually very simple. Then you need to get the weights and center of gravity correct, set up, added in. And then if you have tooling that's going to be used for this operations, you would have to get the colliders on and maybe some buttons activated for running the hydraulics. That's also fairly easy to do. So yes, you could simulate a full tie-in operation.
Yeah, it would be interesting to do with sort of L spools and Z spools.
I think last time we were also talking about flying leads and how those are possible to simulate with the component to simulate those flexible cables and umbilicals. Yeah, but perhaps for pipes you would use a different geometry setup, I think.
There are Unity packages where you can create these pipes and tubings rather easy. The one I would like is where I can click on a CAD model and have it automatically create that EFL for me, for instance, in the shape that it was coming in from the CAD model. I haven't found that yet, so that might be one of the things we need to look at, so I don't have to do all the manual work of setting up EFLs.
There's some functionality we've been looking in, which is kind of semi-automated creation of ropes or some sort of leads when you at least set the points, the main points on the path, and it just creates the lead through those points. So you just have to create points in space. Yeah, I don't know, Scott, we could open for more questions.
Anybody? Gavin, do you have anything you'd like to know or discuss, or Stephen?
For me, the only thing that I was interested in from the whole presentation was good, but the thing that quite stood out for me was the tether part, the TMS. How do you guys find it with that, like a really heavy scene, and when you have your tether with full collision on, does it have a drain on the performance, or how do you see that guys working for you guys basically?
I haven't seen any issues with that.
Yeah, we've specifically used quite a lot of effort for making sure that performance is good on the tether. So we're using very specific code that's meant for longer and realistic umbilicals that can still collide and don't impact performance. And we know that traditionally it can be an issue, and we've been there. This is not the first simulator we've created around the ROVs. So kind of we learned the hard way that we need to be very mindful about the performance of umbilicals, especially when they're colliding, especially when they're long, and we're supporting now several ROVs in the scene with several umbilicals. So that's the bit we had to address quite seriously early on in the project, and at least within the use cases that we've been addressing now, it seems to be formed quite nicely.
Yeah, that was all for me. I actually have to run for another meeting in a few minutes, so it was really interesting, and it looks like you're doing great work there. So yeah, nice meeting you guys, and
Great.
Thank you, Gavin.
Yeah, thanks very much. Anybody else? Also, John, if you want to type something, if you have any questions, John House, you're welcome to ask something you want in chat. Or perhaps, Stephen, you have a question? And if not,
no questions from me, but thanks a lot for the presentation. I've enjoyed it.
Great. Thanks for joining us. And yeah.
Maybe I could ask an open-ended question of if there's interest for the training systems in this group, or if the interest is on the engineering side. So because we've been talking about the engineering features mostly, and we haven't started even talking, because that's a whole another topic on training systems and training simulators for ROVs. if there's any interest in that, and or if this group is mostly concerned about engineering. Maybe still a question. Maybe a question to Stephen.
I might just pop in there. I've always found that on projects that animations are quite handy for understanding how the work's going to happen. So I can see a big benefit there in having some animations for people who are going out on the job, basically.
What if we could export the whole content of the simulator as a game to the user, and they can go in and fly around with the camera to look at stuff, trigger animations on the fly?
Yeah, I think that would be an excellent feature.
Yeah, that's all possible.
It's great feedback. Yeah.
Which again, I think with the common off-the-shelf hardware makes it a lot easier for you to do that as well.
Yeah, absolutely. So that's a significant improvement over just video, basically, you're saying?
Yeah, that's correct. Being able to get in there and interact with the manipulators would be a good thing. Definitely.
Great. Much appreciated.
But I would also mention that when we went offshore some years ago for myself, but then I had the simulator with me, and we had to show it to the crew on board, and that was really helpful because a lot of people, they are joining the boat and they actually don't know what the next task will be. So then we was in the cinema and we were running through like a designer view, and everybody got another impression of what they should do, and we can also focus on special areas where it was have to take special care, and also on the product itself, and also for the people on deck. And that was really good, and everybody had a good understanding of what the job was to do in the job. So
also for working with as-built. So if you have a structure that's been 3D scanned, you can just pop the point cloud straight into the simulator and fly around and check it with combined with the other 3D models if you want to.
Yeah, really appreciate everybody's participation. I hope you got something out of it as well. We'll follow up with a link to this recording, and then maybe, I'm not sure if you have the contact info on the screen, but
sure, I can share that. Yeah.
Briefly share that. You can snap a screenshot if you'd like to reach out. Yeah, thanks again for. We've got one person chatting. Oh gosh, I didn't see you in the chat before. Okay, great. Yeah. Well, Kumar, thank you very much. And yeah, feel free to reach out if you'd like any more questions or anything like that. All right, thanks again, everybody. Have a great afternoon or evening, wherever you are, maybe morning. And we'll see you again sometime, I hope.